Hi guys, it's me again. I'm trying to see what I have to do. All right, just a second. I'll get organized. I think this is about right. All right, good thing we have smartphones and smartwatches. So, hope you had a great weekend and you're ready to learn a totally new concept. We're going to do integrals. Chapter 6 is on integrals of a function. And the 6.1, I split 6.1 to two sections. By the way, the assignment's going to change a little bit. So when we get to the end of this lesson, make sure you write down the numbers that I have changed it to for 6.1a. If you did the first whatever, that's going to get stuff that's in 6.1b. Whoa, my cat's on the board. No good. All right, so that's intervals. So number one, antiderivative and integrals are the same word. They mean the opposite of a derivative. So whenever you subtracted before, you add now. Whenever you multiplied before, you divide now, and so forth. So for instance, if you had x squared and you found the derivative, you had x to the third over, or 3, you had 2x to the first. You went down 1. You subtracted 1. You put the 2 in front. You went down 1. Whew. Took me a minute to memorize that. All right, now we're going to do the opposite. So we're going to add now. So the antiderivative is with a capital letter F. Don't ask me why. Capital letter F1, that means your derivative, equals the little f of x, that means your original, plus k. That's going to be a big concept. You always have to remember to add k. Adding k is going to mean you could add in any number, because remember, what's the derivative of k? 0. So in any function, you can add a k, and the antiderivative, it would be any k, would be that way. All right, here we go. So they don't start with rules first. They start with, let's see if you can figure out the rule first. So let's see what we got. Example, if I derived x squared, you would move 2 to the front, and then you'd subtract 1, and you'd get 2x. Y'all know that. That's easy. You did that like for the last 3 months. Okay? The antiderivative of 2x to the first, then, is going to be the opposite. Remember, you put it in the front and you subtracted 1? Well, now you're going to add 1 and divide it by that number. So whatever was the exponent, or is this new exponent, is going to be what you're divided by. So 2 to the 1 plus 1 over 1 plus 1 means 2x squared over 2. The 2's conveniently canceled. You get x squared plus k, because again, you could have had any different constant added to that. And if you derived it, you would have taken it out. All right. So that leads you to rule 1, which this rule 1 and that rule 1 are going to be the same, so that's good. It's the antiderivative. It's called antiderivative here. On the next page, I call it the integral rules. So this is the only one I call the antiderivative. Means the same thing. It's basically a power rule, x to the n. Big F of x is now going to be x to the n plus 1 divided by n plus 1 plus k. Write that rule down. The one in aqua. All right. So we're going to use that rule for these couple problems here, examples, and then I'm going to give you 3 more rules. All right, for the antiderivative of f of x equals x to the 5th. So if you follow the rule, we're going to add 1, x to the 5 plus 1 over 5 plus 1 plus k, which is going to be x to the 6th over 6 plus k. Now, a couple of you are going to get this assignment really fast, or you're going to get this rule really fast, and you do not have to write every section. If you went from x to the 5th and you knew to add 1 and put it over it, you could go straight to x to the 6th over 6 plus k. The rest of you, especially when it's fractions like the next one, it's going to take a little bit more time. Okay? All right. Next problem on this page, we have find f of x to the 1/2. So you add 1. Well, 1/2 plus 1 is x to the 3/2. But when you put it over 3/2, now what do? Technically, you multiply by the reciprocal, or you flip and multiply. Now, if I was at school, I'd be doing this flipping thing all the time. So I would rarely write 3/2 on the bottom. I just flip it automatically and write 2/3. But technically, you flip and multiply. The 2/3 comes out on the bottom. The 2 over 3 becomes on the top. So it's 2x to the 3/2 all over 3 plus k. Another term for derivative or antiderivative is the integral symbol. So now here's a symbol. Now this is going to be interesting because whenever the other squiggle and the dx, that's kind of like a closed parentheses part of it. That means find the antiderivative, which is the integral of some function, is going to get some other function plus k. All right, I'll let you write that down a minute, and I'll see if I can turn this down a little. I don't know if you can hear the background. Lovely music. There we go. All right. Do you have that integral symbol? F of x dx equals f of x plus k written down, and that's our integral signs now. All right. Now on the next page, I have a lot of examples, but that's going to help you. So you can practice all these examples and see what I do, and then you can go practice your homework. And it'll be 6.1a. All right, I'm going to put this board down, and I'm going to show you 3 rules. All right, so here we have rule 1. It's the same rule as I just wrote over there, but I read it with a squiggle. The squiggle means integral. The integral of x to the n dx is called the power rule. It equals x to the n plus 1 over n plus 1 plus k. So that's exactly the same rule I wrote on the other one, but I didn't have the squiggle and the dx. Rule number 2 is if you have a constant. This one's a fun rule. So if the integral of a constant dx, remember again, the dx is just like the ending parentheses of the integral squiggle. Okay? Whenever you have a constant, you have x to the 0. If you add 1, you have x to the 1. So you literally stick an x on any constant. Constant times x plus k. That's a different constant. That's the constant rule. All right, third rule, it's the subtraction and addition rule. And every time you have a subtraction and addition rule, basically you do each term separately, and then you do the squiggle of the first plus the squiggle of the second. So integral of f of x plus g of x, unparentheses dx. Again, there's that front parentheses, back parentheses of integral. Find the integral of the first term plus the integral of the second term, or if there's a minus sign, notice you do the minus sign. And I wrote add and subtraction rule over here. All right, so those are your 3 rules, and that's the only rules that we're going to go over on the homework tonight. Today. But there's some tricks to the trade, so don't think it's just that easy and you can go skippity-doo-dah. All right, start simple. Example 3. All these are find the integral. I don't even say that because that squiggle means find the integral of 5 dx. Well, 5 is a constant. So over here, I said which rule? So constant rule is that rule. So that means just add an x, 5x plus k. That's the answer. I used rule number 2. Okay, integral of x to the 4th dx. So what do you do on a power rule? Hopefully somebody's out there shouting, you add 1. X to the 4 plus 1 over 4 plus 1 plus k. Do the math. X to the 5 over 5 plus k. Which rule did you use? You used the first rule. Letter C. 3x to the 4th dx. I did not write this as a separate rule. The book does on page, whatever page it's on. Page like, I don't know, whatever page it's on, 400 something. But I didn't put it as a separate rule. You just bring that along with it. The x is the term that has the x. So that's the term you do the power rule to. So x to the 4 plus 1 over 4 plus 1, that was x to the 5th over 5 times 3. That's what you do. 3x to the 5th, all divided by 5, plus k, and you still use rule number 1, the power rule. All right, letter D. I don't know if you can see these, so I'm going to start handing them out. Integral of x squared plus x cubed dx. So you have 2 terms, so you just integrate each separately. So make sure you do each separately. Oopsie, I'm a half on, half off. Which side's off? Nope, this side. There. All right, so it's x to the 2 plus 1 over 2 plus 1 plus x to the 3 plus 1 over 3 plus 1 plus k equals x to the 3 over 3 plus x to the 4 over 4 plus k. This way. There you go. All right, so example 4 is where we have some tricks of the trade. So here's one of the tricks of the trade. 1 over the square root of x. Oh, I haven't talked about square roots, and I haven't talked about denominators. Well, we don't have denominators. And if you listen to, I forgot to mention, there's going to be a video. I need to give you, I'll give directions. I need to give you the code, I guess it's called, like enrollment key or something. It's a password. So I'll have to give that to you online. But anyhow, it's good. There is no product rule. There is no quotient rule in integrals. Okay, so we have to do something else in that way. So this is 1 over the square root of x, so you move it to the top as x to the negative 1/2. There's a power rule. So I'm going to add 1. X to the negative 1/2 plus 1, negative 1/2 plus 1 is x to the 1/2 over 1/2. Flip it, 2 over 1. That's the answer, 2x to the 1/2 plus k. You do not have to have the 1. Notice I just flipped the denominator. Reciprocated it would be the correct word. All right, this one says for cube root of x to the 5th dx. Cube root of x to the 5th. So I have to change that cube root of x to the 5th to x to the 5/3. That should be something you've already learned along the way. And I'm going to do the power rule. Again, the 4 just kind of attaches. Power rule, 5/3 plus 1 over 5/3 plus 1. 5/3 plus 1 is the same as 1 is the same as 3/3. So 5/3 plus 3/3 is 8/3. So 4x to the 8/3 over 8/3. Now this one, when you flip it, that 8 is on the denominator. You do 3 over 8. 4 and the 8 cancel. Well, reduce. So now I have 3x to the 8/3 over 2 plus k. My watch has gone off, so I don't know what's going on there. Hopefully we're still recording. All right. Last but not least, but it's a fairly long one. Notice the assignments on the bottom. I'll keep this up there for a minute at the end. Right now, integral of x to the 3/2 minus 2x all over x, the square root of x, dx. What have I told you to do with singletons all along? Hopefully somebody said split them. Yes. So you're going to have x to the 3/2 over x to the 1/2 minus 2x over x to the 1/2 dx. I should have had a parentheses around that. Sorry about that. Okay. Now, x to the 3/2 and 1/2, you subtract the exponents, that's 2 2s, so that's just x to the 1st. X to the 1 over x to the 1/2, 1 minus 1/2 is x to the 1/2. Now I have 2 power rules that I can do. So the first thing you do is clean it. After you split, you clean them up. Number 1, split, clean up. Wrote it down that way. Here's number 3 over here. Now we're going to integrate it. Now we're going to integrate x to the 1. 1 plus 1 over 1 plus 1. Integrate x to 2x to the 1/2. 1/2 plus 1 over 1/2 plus 1. Do some math. Clean it up. X squared over 2 minus 2x to the 3/2 over 3/2. But I flipped that 3/2, so it's 2/3. And that 2 times that 2 is 4/3. So I get x squared over 2 minus 4x to the 3/2 over 3 plus k. That's your answer. I put 1 or 2 other tricks on your homework. One's a multiplication, one's a division. I want to see if you guys can figure it out. Tomorrow's hangout will be the same time, 9:30 and 1 o'clock. So hopefully you can see me at 9:30 or 1 o'clock. I will also write that on Schoology. But please listen to these videos before. Okay, your assignment. 6.1a. Again, I don't know what page. My book's on the floor. Number 11, 13, 19, 20, 29, 32, 34. I shall repeat. 11, 13, 19, 20, 29, 32, 34. That is not what is on your syllabus. It starts out the same, but is not the same. We'll pick up the rest of the problems tomorrow when we learn some more rules. Fun times. All right. I am going to put the board down. I'm going to look at my watch, knock over things. And I don't have my watch, so I'm assuming that I'm still on there. I will shut the power off now. Thanks. I'll talk to you at Hangout.